Alright guys, so today we're gonna look at exercise 7.2, Math NCERT textbook, chapter integrals. So we're gonna start with the first question. Uh, Before that, I'd like to comment on things, a quick note. In my previous video, I did mention a trick to do with exponential powers. Okay, so very simple is, if you have a function, f of x, okay, such that, okay, such that you have two distinct values, you have two exponential powers. One is x raised to the power n and x raised to the power n plus 1. Okay, so you have a function x, a function of x, such that it has two values, x raised to the power n and x raised to the power n plus 1. Okay, now this x raised to n plus 1 can have some value k attached to it. Okay, this k is some constant value. Think of any real number, 1, 2, 3, 4, 5, 100, 200, a million, whatever, and some other constant value, let's say k1 multiplied to it. Doesn't matter, these constant values don't matter. What really matters are this value. Okay, this and this. Okay, now what is the most important thing? Okay, now if you find this value can either be in the denominator or numerator, but this value must always be in the numerator. Remember this. So remember, must always be in the numerator. So if these conditions are fulfilled, all you have to do is take this value and equate it to t. As simple as that. Understood? That's the easiest trick I can tell you. So let's see a few examples based on this trick. Okay, so we're going to start off with the first question. Okay, which is very simple. Now this x of n again can also have a constant value multiplied to it, only multiplied to it, not added, just multiplied. So some value, let's say k2. Okay, some value, it doesn't matter, as long as you have x of n, x to the power n in the numerator and x to the power n plus 1 in the numerator or denominator. Equate this value to t. Simple. Okay, so let's start with this. So 2x divided by 1 plus x squared. Let's find the integral of this. Now this looks like the exponential power, right? So what is your x of n over here? Correct? What is your x of n? Your x of n is x. We can see that. And what is your x of n plus 1? Okay, so something like k1 plus k, right? So this one is what? X squared plus 1, right? Your k is 1. Your k1 is also 1, so it's like 1 times over here, so 1 times this. Simple, right? Now, is this in the numerator? Yep, look at the question. It is in the numerator. Is this in the numerator or denominator? Yes, it is in the denominator. So therefore, all I have to do is, I have to write x squared plus 1 is equal to t. And then differentiate on both sides. The x, this portion, which is a function of x, after differentiating, which is, let's differentiate, which is 2x. Now 1 goes to 0, so you don't have to worry. Dx, remember, when you differentiate on the x side, the whole thing should be multiplied with dx, is equal to t. What's the differential of t? Is just 1 times dt, right? Correct? Am I clear? So what do we have? So we have 2x dx. right? And we have these two substitution values. Do we have 2x dx? Yes, we do have 2x dx in the numerator. That is great. Even if you took 2 to the other side and you got x dx, that's also fine. It will cancel out. Don't worry. Okay, so let's substitute. So this will be equal to integral. So 2x is what? dt. 2x dx. So 2x times dx is dt. And this will be dt over t. Now what is the integral of 1 over t dt? Okay, that should be, I'll point it out. Give me a second, let me erase. Okay. So this is the formula, right? On your formula sheet is equal to the natural log of x plus c. Okay. Which is equal to, is it the natural log or is it, yes, okay. I think it's gonna be ln, but yep. Anyways, forget that. Just follow what is given is equal to log of t, because t is in the denominator, plus c. Right? Now go back to the substitution. We have to change it to form of x. So we found the integral. What is log of, what is t? T is x squared plus 1. So we have log of x squared plus 1 plus c. Wasn't that simple? Right? So again, if you follow these conditions which I've given here, for any x squared value in this particular exercise, you can solve this. All right? Doesn't matter what the k value is. And remember, just don't take x squared, because x squared has a constant next to it. It's not in the form of ax squared plus bx plus c. Right? It's not like that. There's no x squared plus x plus 1. So you don't have to worry about that. All you have to worry about is when you see, if you see these conditions apply, these conditions fit the profile for the integral, apply them. As simple as that. Okay, and let's move on to the second question. Now let's see. Okay, so I'm not going to do the second, fourth, fifth, sixth. Okay, let's do the sixth. So I'm keeping track here which all questions I've done. So I've done question, if I'm correct. Okay, so I will keep a track here. So I've done question 1. How many questions are there? There are 36. So let's do that. 1, 2, 3, 4, 5, 6, 7, 8, 32, 33, 34, 35, and 36. So I am done with question number 1. Okay. Now I'm doing question number 6. Interesting. Okay. So let's do question number 6. Okay. So square root. By the way, I will do the other questions. I'm just doing for this particular type so that you understand. So this is integral dx, right? Okay, interesting. Now, what will be your, do you see an x to the power n? And all you have to do, you can write k2 as well, no problem. But the most important thing is this. And then you have k1 to the power x of, to the power n plus 1 plus k. Right? So you have to see if you have this. Do you have x raised to the power n? Or do you see an x raised to the power n plus 1? Now, you might see ax plus b, and you might be thinking, what should I take this as? Should I take this as x to the power of n or x to the power n plus 1? Okay, if you take Now let's do this. Now let me make it simple for you. So you're saying this and you want to take this. So this, sorry, delete. Okay. So you're saying, so you're confused as to whether I should take x as x. So you have x to the power n and x to the power n plus 1. Okay. So let's do this. Now you can't decide whether x to the power n or x to the power n plus 1. Okay. So let's play the scenarios, right? If I would have taken this as x to the power of n, then my x to the power n plus 1 must be x squared. Do I have an x squared anywhere in the equation? No. Okay, good. So that failed. Now, what if I take x as this, x to the power n plus 1? Therefore, my x of n would be what? X. So this is x to the power 1, right? And n plus 1 is equal to 1. So therefore, my n is equal to 0, right? So my n is 0. So do I have x to the power 0, which is equal to 1? Yes, I do have. So this is x to the power 0. I can just multiply. 1 is always there, regardless. It's always multiplied, right? So what should I take my... Sorry. What should I take? So this is x to the power 0. Okay. What should I take my x to the power n plus 1 as? Right? Not x, but this whole thing. Right? Because it's multiplied by a constant a. See, I told you the k1 and k is very important. Okay, take the whole thing because they're constants. They'll go away. Okay, the factor that's multiplied will go on the other side and this will become 0 when you differentiate. So therefore, I have to take this part is equal to t. And again, does it fulfill the condition? Is this in the numerator or denominator? It's in the numerator. It fits the condition. It can be both. It can be either in the denominator and numerator. Well, it is. And what about x to the power 0? It should always be in the numerator as per our condition. Remember that. And is it in the numerator? Yep, it is. So let's do that. So then all you have to do is take ax plus b is equal to t. Now let's differentiate. Remember, a and b are constants. Okay, some number 1, 2, 3, 4, I don't know, all set of real numbers. So let's do this. So let's differentiate. So when you differentiate this, a comes out, differential of x is 1, so you know it's a. Differential of b is 0 is equal to differential of t is, you should know this by now. If this is 1, this comes here, and then you subtract 1, t to the power 0 times 1 is 1, right? So 1 times dt. And remember, don't forget, this is dx. So what do you have? A dx is equal to dt. Now, do you see any way a dx? No, so take a to the other side. Remember, a is a constant, don't worry, it's not x. So dx is equal to 1 by a dt, right? And can you substitute these values? Remember, if this was x, you couldn't take x to the other side because basically it's x dx. Then you should find x dx in your function, but it's not there. Okay, right? By the way, this is not x dx, this is x raised to the power 0, which is 1. Don't get confused, remember that. Okay, so let's change this. Okay, so let's do this. Integral of root of t, because ax plus b is equal to t. Just let's remove this for now. I don't like this, right? And this is your dx. These are the substituting values, right? So root t times 1 by a. 1 by a is a constant. Well, anyways, I'll write it here. dt. So 1 by a is a constant. Bring it out. 1 by a integral of t to the power half dt. Now how do you integrate t to the power half? Easy, add 1, which is integral of t to the power half plus 1 divided by half plus 1 plus c. I'm sorry. Again, my bad. I'm sorry about this. So this is no integral. Okay, so what is half plus 1? So those who are wondering how to do half plus 1, remember you want to make this like fraction, so you've got to, so this is 1 by 1, you multiply by 2 to make the denominator same, but if you multiply 2 here, you have to multiply the denominator. So it is half plus 2 by 2, add the numerators, add this numerator, which is equal to 3 by 2. Okay, by the way, 1 by 8 times, sorry, 1 by 8 times. So remember these two are equal, which is equal to 1 by a times t to the power 3 by 2 divided by 3 by 2 plus c. This is correct. Now if I want to bring this to the numerator, I have to invert it. 3 by 2 becomes 2 by 3, which is equal to 1 by a, god, my a is horrible, okay, which is equal to 1 by a times 2 by 3 times t raised to the power 3 by 2 plus c, which is equal to, I multiply these are easy, so I like to write 2 by 3a, okay, and then substitute for t. What was t? Ax plus b. So times ax plus b times raised to the power 3 by 2 plus c. So let's see if our solution is correct. I'm just confirming with my notes. So it should be correct. Yes, it should be correct. It is correct. Okay, so that was a substitution for exponentials. All right. So exponents, sorry, not exponential, exponents, whatever. Delete, and this delete. Okay, so I think I'm done with the 6th, right? So 6th is done. Let's move on to the next. So after the 6th, I'm going to do the 7th question. Interesting, right? 7th, right? Now this is a good case again. So x root of x plus 2 dx. Now you come across an interesting case. The powers are the same, so you don't have an x of n plus 1, so we've got a new case, right? A new trick. Basically, if the powers are same, now the new one, okay? So if there is a function f of x, okay, such that you have a value k of x of n and another value k1 of x of n plus k, okay? Now does it matter which is in the numerator and denominator? Yes, it follows the same condition. Now both are an n, same power, correct? So let me highlight that again. It's the same case, just slightly different. Okay, so both have a raised to the power n. Okay, so this is k2 if I'm not mistaken. Okay, this can be either in the numerator or denominator again, but this has to be in the numerator. Okay, if they have this, if it's x raised to the power n, right, what happens? It doesn't matter. You follow the same thing and substitute this as t. Simple. Okay, as simple as that, as simple as it gets. Okay, but in this case this is very unique because x is to the power 1. Okay, it doesn't work all the time. Okay, so n in this case must be equal to 1. Because if this was x squared, then you would need x dx at the very least. Right? So if this both were x squared, you would need x dx. Right? Now you'll understand what I mean. I will not waste your time. But remember, this n should be equal to 1. So only if it is to the power x. In fact, let me make it simpler. Look at that and look at that. Okay? Look at that. Okay. That is much better. So this is x. I'm sorry. X. Okay. So let's do this. So which one would I take? I would take the one in the square root. That's easier to do, right? Because root of... I wouldn't take this x to be t. This wouldn't make sense. This would make sense because I'm reducing it to a much smaller value. Why would I substitute x and then t? Okay, so let's do that. So now x plus 2 is equal to t. By the way, this is an integral. I forgot that. Okay, so what is the differential? It is dx because this becomes 1 and this becomes 0. And then add them and add dx. Multiply by dx. This becomes 1 and this becomes dt. So dx is equal to dt. But now you are asking a very... Now a question comes, what do I do? What do I do with this x? Correct? Because now you will substitute and you will say x plus 2 is there, is equal to t. Correct? And dx is equal to dt. What about this x? Shouldn't there be x dx? Well, because they are the same power of 1, this is an interesting thing. You can use this to substitute this value of x. So you will get a third substitution, x. So x plus 2 is equal to t. You know this. So x is equal to t minus 2. This will be your third substitution. So let's do that. So integral of t minus 2 square root of t, and you know dx is equal to dt. Now you're thinking, how is this going to help? We'll see. Now what do? You open the brackets, which is integral of t times root of t minus 2 root t, the whole thing dt. Simple, right? So I just open the bracket, multiply this with this, multiply this with this. This is what you get. Now you know the basic rules of integration. Now you have to integrate them individually. So integral of t, okay, times t raised to power half minus 2. So this is dt. Sorry. So plus minus 2 times t to the power half integral dt. Right? So we can do this, which is integral of... So you know how to multiply this, add the powers, which is 1 plus half is 3 by 2. We did this in the previous question, how to add the powers. Dt minus 2 raised to the power t to the power half dt. Now, how would you integrate this? So simple, you know this, plus 1, and then 3 by 2 plus 1, and then again half plus 1. Right? So what is 3 by 2 plus 1? Right? So 3 by 2 plus 1, just add 2 to the numerator, which is integral of t raised to the power 5 by 2 divided by 5 by 2. Not integral, my bad. Even I keep making silly mistakes, so be careful of that. Minus 2 times t raised to the power 3 by 2 divided by 3 by 2 plus c. Right? Now all of these are equivalent. So this will be equal to, let's do this. Now 5 by 2, if I bring it here, becomes 2 by 5, and this becomes 2 by 3. Okay, so this is 2 by 5 t raised to the power 5 by 2 minus 2 times 2 by 3 times t raised to the power 3 by 2 plus c. Now I'll simplify this. 2 to the power 5 t raised to the power 5 by 2. Okay, well, let's make it simpler. It's not complicated. I think everyone can do the multiplication. Let's just substitute t back. What was t? So t was x plus 2, right? So let's do that. Let's do that. Okay, t was x plus 2. So 2 by 5 times x plus 2, alright, to the power 5 by 2 plus, no, it's minus, my bad. I'm not a fan when there's a lot of jumble. Minus 4 by 3, because 2 times 2 is 4, times x plus 2 to the power of 3 by 2 plus c. This should be your answer. So let's confirm that. Which question is this? This is question number 7. And I am checking it. So as per the notes, 2 by 5, x plus 2, okay, 4 by 3, x plus 2. Okay, I'm right. This is correct. As per the solutions, it should be right. Okay. Okay, I think everyone understood now. So this was a bit long. This was a bit longer because of the, the powers being square roots and square roots to the power of something else. It took a bit of time. Anyways, the simplification, I think everyone understood that. Let's move on to the next question. Okay. Okay, so because we're done with 7, let's cancel 7. Okay, now what's the next question? Let's see. 7 is good. 8 is interesting also as well, and it's quite simple. So now you have to tell me. This is very simple. This is very simple, right? Now you're saying exponents. So does it follow this case, right? So what it, and I'll do it again, no problem. So do we have of k2 of x of n, x to the power n? Yeah. And do we have a k1? Now this k you can write whatever you want. I just made up this for this thing, right? So x to the power n plus 1. Forgive me, my x sometimes looks like n, so just bear with me, just listen and just comprehend as I'm saying, because I know it looks like, so plus k. Okay, so what is my x of n plus 1? So if you know this, you would say this would be 2x squared plus 1, and this would be, I think, x. If you got that, you're on your way. You understood the trick. It's very simple. And what do? Equate this is equal to t. It's the same thing as t. Okay, so let's do that. So 2x squared plus 1 is equal to t, right? So what is the differential? What is the differential? And you can compare. See the x squared. This is x squared of n plus 1. Therefore, this will be x to the power 1. Simple, right? This would be x to the power 1. Simple. Okay, let's do this. So let's differentiate, which is 4x dx is equal to dt. Correct? Now, what do you need? Oh, sorry, I forgot this. You need x dx, right? This is your t and this is your x dx. So x dx is equal to 1 by 4 dt. Okay, so let's simplify this. Now this is equal to the integral of, so I'm going from here all the way here, right? so you have x dx, and then you have 1 plus 2x squared, so that is root of t, which is t raised to the power half. Now I'm going to the shortcut now, and this is dt, correct? T to the power half. Does that look like to the power half? It looks like t times half, but I'll make it better. Okay, I think that looks better, and I think people know how to do this. So plus 1, again, for those not familiar, half plus 1. Half plus 1. Okay, so which is equal to t raised to the power 3 by 2 divided by 3 by 2 plus c. Bring 3 by 2 here, which is equal to, remember when you bring it up it inverts, so 2 by 3 times t raised to the power 3 by 2 plus c. Now what is your t? T is 2x squared plus 1, which is equal to 2 by 3 2x squared plus 1 raised to the power 3 by 2 plus c. So let's check this answer. This is which question? Again, this was question number 8. Okay, my bad, I forgot to change this. 8. Okay, so question number 8 should be correct, right? Should be correct. Your solution might show something like this because I changed the order over here. It doesn't matter, it's the same thing. 2 by 3 times 1 plus 2x squared 3 by 2 plus c. This is what your textbook shows. This is also right, it's just the order has changed. It doesn't matter. If you know the laws of addition, you should be good. Okay, let's move on to the next. Okay, I have to mark that 8 is done. Okay, good. Oof, long way. So we have 32 questions to go. Let's do this. Delete. And this one. Delete. Okay. Let's see. Now what is the next question? That is very similar. So 8, 9. 9 is very interesting. 9, yes. 9 is a unique case now. Alright? 9 is a very unique case. Okay, let's do this. 9 is a good case, and this is a new case you're going to see. Usually you had constants, but now you're going to get in the form of ax squared plus bx plus c. And this is one thing I like about this. So 4x plus 2, and then you have square root, and this is showing me what all possible conditions could come in a question. X squared plus x plus 1. Now usually when you see a square root, I think by now the intuitive approach is to take this as equal to t, and you're absolutely right. Sorry, this is the way it is, and you're absolutely right. Right, this is what you must do. But let's form an understanding as to why. Because when you differentiate this, the power becomes 1, so something like 2x, right? And very similar to this, you're getting this and dx, so you can easily substitute the differential value. You should get something close to this. Okay, so enough talk. Let's understand what is now the case of this. So in situations, now this is again, it's kind of the same thing, right? You have the same power of x raised to the power n, correct? It follows this same condition, but now the equation is a bit different. So if you have an equation such that, now this is a quadratic equation, in this case quadratic equation, or any equation such that you have a raised to the power, and so doesn't matter what it is, so a times, if you have an equation such that a raised to the power x of, 1 minute, let me try this here, a raised to the power of a times x, so a is some constant, like this is 1, x raised to the power of n plus 1, plus b raised to the power of x of n, okay, plus c, which is x raised to the power n minus n, x raised to the power, sorry, apologies, x raised to the power of n plus 1, x raised to the power n, then x raised to the power of n minus 1, and so to some value k, some value k raised to the power x to the power of 0, which is 1, some value like a constant, right? This would be your equation, right? And then you have also something that is lower than this, so this will be n minus 1, so something like p raised to the power of x raised to the power n plus q raised to the power of x raised to the power of n minus 1, right? So and so till some constant k raised to the power of x raised to the power 0, which is basically k1, this way, right? So what is my n plus 1 value here? It's 2, right? So if my n plus 1 value here, then what is my value over here? N, which is 1. So if n plus 1 is equal to 2, n is equal to 1. Very simple, right? It's actually the same thing as what we did here before, but here we have quadratics. Before you didn't have the x squared plus x, you just had x squared plus 1, right? So it was a lot easier at the time. Now you don't have, you have a different scenario. It applies the same. I'm just writing an equation form. Follow the same thing. If you get confused by this, okay, don't be confused. As long as you understand this, it applies the same thing. Okay, so I'm just going to remove this because I think a lot of people might get confused about this. If you want, you can try to understand later, but the simplest way I can explain is it applies this. So what is your x raised to the power n plus 1? Apply it. Okay, it is this whole equation. This whole equation is x raised to the power n plus 1. Is it in the numerator or denominator? Yes, it is in the numerator, so it holds true. So it's holding true for this condition. Is x raised to the power n, so which is it? 4x plus 2. Is it in the numerator? Yep. You don't have to worry. Correct? All you have to do this is now equate this to t. So x squared plus x plus 1 is equal to t. Now, what do? Differentiate. 2x and x becomes plus 1 is equal to, so this is dx is equal to dt. By the way, multiply this. Now you're asking, where is 2x plus 1 dx? Well, it is there. The only thing is you didn't see as this equation can be written as 2 is a common factor. So this will become 2 times 2x plus 1, right? Square root of x squared plus x plus 1 dx. So the integral, sorry. Right? Okay. So let's do the substitution. We got it. I hope you're getting a hang of this. So let's do this. So integral of 2 times 2x plus 1 dx and square root of t. So t raised to the power half dx. You understood why, right? Because 2x plus 1 times dx, which is this 2x plus 1 times dx is equal to dt, and this is equal to t, so square root of t. Now 2 is a constant, it comes out, so 2 times integral of t raised to the power half dt. We've done this already so many times, add 1, and this thing is almost getting boring. So 2 times t raised to the power 3 by 2 divided by 3 by 2 plus c, right? Now if you bring this up, it inverts the inverse of it. So 2 times 2 by 3 t raised to the power 3 by 2 plus c. Now substitute whatever t is. What is t? So 2, so this is 4 and this is equal. Give me a second. Don't want to cause any confusion. So integral, right? Okay, is equal to 4 by 3. So what is t? T is x squared plus x plus 1. Okay. X squared plus, oh god, I'm so sorry, x plus 1 the power, I'm substituting it back, 3 by 2 plus c. I hope this clears everything. Okay? An important question, keep in mind. Do you see? I think you can start finding the questions based off this. If you really understood this, you would start finding the questions. You might predict even what my next question is. That should be the interesting part. Okay? So do a little experiment yourself and see. So, by the way, did I get the answer correct? I want to just see that. Wait. Because, is it correct? Because I don't want to make mistakes for you guys. Yes, it is correct. So as per the solutions, it is correct. Sorry. So I don't have to worry. And again, delete. Okay. Now. Okay. So we did question number 9. Okay. So you should be able to predict which is my next question. So you should be able to filter out these type of questions right now. Okay. So one. Okay. Okay, I think the 10th might fit very well. So let's see the 10th one. I was just looking at it and I'm thinking, how would I solve this? Oh, okay. Correct. Okay. Now, no, I won't do the 10th because it's not similar. It is a very unique case, so I won't do the 10th. 11. 11, yes. 11 is the same as what we did in question number 7. It's very similar. It's the same thing. Okay? So x divided by square root of x plus 4. Right? The powers are the same. You know, this is in the denominator, so we will take this as t, right? Because it's easy. Remember, the substitution value must always be in the numerator. Simple, right? By the way, if you're a bit confused, this whole thing is f of x, because I think maybe people, when I said f of x, didn't know. This is the whole thing, f of x. Okay, when you see this thing and you think what is f of x, the whole thing is f of x. Okay, I just remove this. Okay, so let's do this. So if again, it's following the same rules, right, as this one. Remember this one, similar, right? K1 of x, so I know which is x plus 1, which is x plus 4, right? And is it in the numerator or denominator? Yeah, it is in the denominator. And is k2 of x, because of the same powers, in the numerator? Yeah, I don't have to worry. So let's integrate this. So questions 7 and 11 are very similar. So remember that. Questions 7 and 11 are very similar. You should be filtering out these questions by now. Okay, so let's do x plus 4 is equal to t, which is dx is equal to dt. Very simple. So you will have how many substitutions? Remember, in this case, you will have 3 substitutions usually. 3 substitutions. And you have dx is equal to dt. Also, x plus 4 is equal to t, which you got from here. X is equal to t minus 4. Correct? So we got all the substituting values. So integral of t minus 4 divided by t. T raised to the power half dt. Very simple. Very, very simple. So let's do this. How would you do this? If you remember your first exercise, separate them, right? T divided by t raised to the power half minus 4 divided by t raised to the power half dt. Integrate. So this would be integral. So this would be 1 minus half. So t raised to the power of minus half dt. So I'm integrating them individually, and this would be 4. Am I doing this correct? So 1 minus half. And if I take this up, it would be 4t raised to the power minus half. And I can take 4 outside dt. Correct? So what is this? So I had plus 1 this thing, so it would be equal to what? T raised to the power half minus divided by half, I forgot that, correct, minus 4 times t raised to the power half divided by half plus c, which is equal to, let's backward substitute, which is x plus 4 raised to the power half. Now if you bring this up, of course, it becomes 2, right, minus, okay, 4 times, now if I bring this up again inverts, times 2, which is, let's do it now itself, is 8, right? Because if this comes up, this becomes 4 times 2, which is 8, times x plus 4 raised to power, God, sorry, x plus 4 to the power half plus c. Okay, so this is your answer. Okay, let's confirm this. So this is question number 11. Checking the solutions. So what should be the answer? Okay, it seems to be wrong. Square root. What did I make a mistake? So square root of, oh, okay, my mistake again. See, even I make mistakes. I'm sorry guys. So yep, if you caught the mistake, very good. Okay. Sometimes even I get lost. Okay, let's do this again. Okay, I'm going to put an equal to here, and it's very important we do this because this is 1 minus half is half, right? So this would be integral of t raised to power half. My mistake, I thought minus half, my bad. Minus 4, so this is dt, sorry, minus 4 integral of t raised to power minus half dt. And if we integrate the individual terms, what do we get? What do we get is t raised to the power 3 by 2 divided by 3 by 2 minus 4, this is half, sorry, minus 4 t raised to the power half, if I'm not mistaken, divided by half plus c, correct? So let's substitute and take everything out. So if I bring this up, this becomes 2 by 3 times t raised to the power 3 by 2. So what is t raised to the power 3 by 2? So what's my t? My t is x plus 4, right? So x plus 4 raised to the power 3 by 2 minus, and if I bring this here, this would be 8 times t raised to the power half plus c. Oh, sorry, my bad. X plus 4 plus c. Okay. Now what you could do is you could make it even more simpler, which I think was in the textbook solutions. As per the textbook solutions, they have simplified it a lot more. So I'm gonna bring this down over here. Okay, let's go ahead and solve this. What they have done is instead of moving from this step, let's see, you can solve it right here. This is a correct answer, but what the textbook has done, if you see the textbook and you think, oh, this is a wrong solution, what basically happened was, and I want to do it in terms of t, because if I do x plus 4 it's a bit confusing, because x plus 4 is the same as t, so we'll continue with t so that it's much easier to understand. Okay, so this is equal to, like we did before, so this is 2 by 3 t raised to the power 3 by 2 minus 4 times 2, which is 8 raised to the power t raised to half plus c. Now what they've done is, what they did was, they did 2 by 3, and this can be written as t raised to the power 3 by 2 is t raised to the power 3 times not t raised to the power 3, no, so how would you do this? T raised to the power 1 times t raised to the power half. So they separated the half and 1 together, minus 8 times t raised to the power half plus c. Now between these two, the common factor between this and this, the common factor is t raised to the power half. So what they did was, they took t raised to the power half as a common factor, times, okay, and I think 2 is also is 2 a common factor. So what did they do? Okay, they're getting 2 by 3 at the end, so that they took out 2 by 3 also as a common factor, right? So 2 by 3 as a common factor, so if you take out 2 by 3 as a common factor, you divide by 2 by 3 on each side. So if I divide 2 by 3 here, this becomes 1 and t raised to the power half, so t is left, right? So you divide on both sides, minus, so 8, so let's do 8 divided by 2 by 3, because 8 divided by 2 by 3, now I'm doing this so that it's easier for you to understand. So this is not related to this, okay, so 8 times 3 by 2, which is 4 3s are 12, okay, minus 12. Now t raised to the power half is already taken out, correct? So t raised to the power half, t minus 12 plus c. And now they've substituted, okay, now they've substituted the value of t, which is equal to 2 by 3, so t raised to the power half is x plus 4 times x plus 4 raised to the power half times x plus 4 minus 12 plus c. Now 12 minus 4 minus 12 is minus 8, right? So we know that, so I'm gonna just write it here, minus 8 plus c. So that's how they came up to. But either ways, before with the answer which we got, if you came till here, right, you're pretty much right, so don't be worried. This is pretty much right. Okay, so I don't think they expect you to simplify. If you come here, you're right, they're just equivalent, they're just much more simplified. Okay, that's it. This is all, that was also right answer. This is just a simplification of it. Your job in an integration exam is to integrate. They're judging you based on your integration, not based on whether you can simplify it down to this. Okay, so either ways, if you don't feel comfortable with my advice, don't worry, go down till this, try to understand what I've done, review the video again, you'll get to know. Okay, so this was quite a big sum. I didn't expect it, but something as simple as x by x plus root of x plus 4 turned out to be a very lengthy sum. I guess it's the powers, half and this thing, they're quite irritating to have these kinds of powers. Anyways, we've done it. So let's go question number 11. And we are done with question number 11. So how many questions have we done? 1, 2, 3, 4, 5, 6 out of 36, if I'm not mistaken. 30 more to go. Great. This is a very long exercise. Okay. So I did question number 11. Let's see question number 12. 12, yes, 12 is, I would suggest put this on your radar because this follows the same thing but it's a bit complicated. So x cubed minus 1, right, raised to power 1 by 3 times x raised to the power 5. It's the same thing, it's just polynomials. Okay, now you might be scared. Now the thing is, you're afraid. Now if you saw this question and you thought, okay, if my x to the power n plus 1 is x cubed, therefore my x, if I differentiate it, I'll get my x raised to the power n as x squared. Where do I get this? Where is x squared, right? And if you're thinking, because there are two cases, either you take this as the substitution or this as the substitution. Now remember, when you have something like cube root or square root, you generally take this as the substitution. In most cases, this is one of the easiest tricks. Whenever you see something encapsulated with minus 1 and a constant, right? Anytime you see something like this, exponent next to a constant, right? And you see something like x to the power 5, you will always take this as the substitution. Okay? In all cases, if you see, the one with the constant was always taken. A rare case was, I think the rarest case was question number 9, which we did, which was a quadratic equation, right? And the differential was a linear equation. So remember that quadratic is ax squared plus bx plus c, with the highest degree is 2, and linear is just with the highest degree as 1, right? Okay, so generally is that, and if you did that, if you assume that way, it's correct. But let's see, but you're confused as to what to do now, right? The issue is, if I take x to the power 5 as n plus 1, right, because you can assume k over here to be 0 and k1 to be 1, it's fine, it's not wrong. But you don't have an x raised to the power 4 dx. You don't have that. So the best thing, in my opinion, go with the flow and try to do x cubed minus 1. And I'll tell you why. It will blow your mind, okay? So x cubed minus 1 is equal to t, and x squared dx, 3x squared dx is equal to dt, right? Now you're saying, okay, let's make it x squared dx is equal to dt over 3. Now you're saying, where is my x squared? Well, it's actually here, because x raised to the power 5 can be written as x cubed times x squared, right? Now if you saw it, yes, this is a triple differential. Again, this is triple substitution, because this x cubed minus 1 will be substituted over here. Okay, will be substituted here. Your x squared dx will be substituted as this, and your x cubed, from here you will get x cubed minus 1 is equal to t, and x cubed is equal to t minus 1. That's why I like the exponents with the constants. But if you had something like x cubed plus x squared plus 1, this would be a problem, because then you would need a quadratic equation in order to get this. Okay, anyways, x squared plus x plus 1, whatever. You wouldn't want that to happen. Generally, if you see something with the powers of square roots or halves or this thing, take the inner value, and usually when it's with a constant, that usually 9 out of 10 times or 8 out of 10 times is going to be the substitution value. That's one of the simplest ways to eliminate which one I should substitute for. Okay, so let's go ahead. I think we got this, and x cubed t minus 1 will be substituted as, will be substituted, as we know, as x cubed. So what we did is, we broke the integral down as x cubed minus 1 raised to the power 1 by 3 times x cubed times x squared dx, right? And now we substitute. So x cubed minus 1 is t, so integral of t raised to the power 1 by 3. Now x cubed is what? t minus 1 times t minus 1 x squared dx is dt over 3, right? Just substitute. All the highlighted ones in box, substitute. Simple as that, right? This, this, and this. Those are the substitution values. Anyways, okay, so let's do this. Let's do this. Now, how would you do this, right? First of all, constant, bring it out. So 1 by 3 integral, open the brackets. So this would be, I'll just write it anyways, times t minus what? T raised to power 1 by 3, the whole dt. Simple. Okay, which is equal to 1 by 3 integral of, now you add these, add the powers together, which is 4 by 3, yes, t raised to power 4 by 3 dt minus integral of, now you add 1, integral of t raised to power 1 by 3 dt, right? So this whole thing, which is equal to 1 by 3. Okay, so let's integrate this. You know how to do this. So t raised to the power, so t raised to the power of 4 by 3 plus 1. So this is which question again? Question number 12, right? Okay. T raised to the power of 4 by 3 plus 1 is, so let's do that. 4 by 3 plus 1 is equal to, just put 3 here, so 7 by 3. Okay. Divided by 7 by 3. Okay, minus 1 by 3 plus 1 is equal to 4 by 3. We know that. T raised to the power 4 by 3 divide, sorry, this looks really confusing for you guys. Okay, t raised to the power 4 by 3 divided by 4 by 3 plus c, right? Plus c. Okay, so let's do something interesting. So we can bring this out and this out as well, right? And it inverts. So let's do that. And by the way, you have to multiply 1 by 3 with each of these values. And this, but of course 1 by 3 times c is still c, because a constant multiplied by a constant is a constant. Okay. Anyways, so 1 by 3 times 3 by 7, okay, times t raised to the power 7 by 3 minus 1 by 3 times 4 by 3 times t raised to the power 4 by 3 plus c. Oh, sorry, not 4 by 3, 3 by 4, right? The 3 gets cancelled, 3 gets cancelled. So what do you have? T raised to the power 7 by 3 divided by 7 minus t raised to the power 4 by 3 divided by 4 plus c. I think this should be correct. Okay, so what does that give me is, so now I just have to substitute for t. That's very simple. So what was my t? X cubed minus 1, right? X cubed minus 1. So therefore this is equal to x cubed minus 1 to the power 7 by 3 minus, so this is 1 by 7th of it, minus 1 by 4th of x cubed minus 1 to the power 4 by 3 plus c, right? This should be your answer. And let me check though with the solutions. So 1 minus 1, yes, 1 by, okay, we're right, we're in the clear. So this was question number 12. Good, we're making some progress. Okay. and this 2, delete. Okay, interesting. Everything follows the same things on the right side which I've written, just some nuance changes, whether it be triple substitution or maybe a quadratic with a linear. That's pretty much it. Okay, so 13. Oh, 13. Interesting. So x squared integral of x squared divided by 2 plus 2x cubed the whole power cube, the whole to the power cube. Very interesting. Very interesting in my opinion. This is very interesting. Okay, I think it's easy. I think you should know. Which are you going to take as your substitution? Okay, if you said this value, yes, because first thing, you should see the power is 3. The whole thing is encapsulated in a power. Okay, the whole thing is encapsulated in the power. The second thing you must see, this is an n plus 1. The x cubed is n plus 1 and x to the power n is x squared, which is in the numerator, which is amazing. We just have to check that. Right? You find the x of n plus 1, which is x to the power n plus 1, which is x cubed, and you find the x raised to the power n, and it is x squared. You have x squared. And the best thing is the x squared is in the numerator, so it follows our condition, follows the same thing. It's just an easy formula to apply. Okay, let's do this. So 2 plus 2x cubed is equal to t. Differentiated, so you differentiate, what would you get? You would get 6x squared is equal to, so dx is equal to dt. So x squared dx is equal to 1 by 6 dt. Very simple. So integral, substitute. So these are your two substitution values, right? I'll highlight them if you want. This, this, and this, right? Let's do it. Let's integrate. Simple. So what is, you have x squared dx is, okay, that you can do later, is 1 by t cubed and 1 by 6 dt, right? Now 1 by 6, the force will come outside. We know that it's a constant. So 1 by 6 integral of t raised to the power minus 3 dt, right? Which is equal to 1 by 6. Now how would you do this? It's simple. Plus 1 minus 1. So this would be 1 by 6 minus, so plus 1 minus 1 minus 2. So t raised to the power minus 2 divided by minus 2 plus c. And just substitute t. You know the value of t. 2 plus 2 x cubed, which is equal to 1 by, so 6 times 2 is 12, and this is negative. And what is t? 2 plus 2x cubed to the power of minus 2 plus c. Correct? So which question is this? Question number 13. Okay. Let me check the solution before we go ahead. Did I do it right? I think I made a mistake. Did I make a mistake? What could I have possibly made a mistake at? Did I write the question correct? First of all, did I write? Oh, okay. I'm sorry, guys. This is 3x cubed. Okay, no wonder. So the 3x cubed. I'm sorry, that it's just a minor mistake. It's okay. It becomes 9. This becomes 9, 9, 9, and this becomes 18. 18, and what they have done is basically they've just brought this to the denominator because the whole raised to power minus 2, it's the same thing. I just made the 3 changed everything, so I am sorry about that. Minus 1 divided by 18 times 2 plus 3x cubed the whole square plus c, because if you want this positive, you got to bring it down and then you multiply with 18. It's easy. Okay, that's it. That's pretty much it. Okay, it's just a silly mistake on my side, which is that thing. Anyways, it would have worked the same if you would have done it. Only the thing is, instead of me getting 12, you would have got 18. And anyway, this is also correct. There's nothing wrong in this. It's the same representation. Nothing wrong. Same representation, different value. Okay. So we're done with question number 13. I think this is becoming a lot more easier for you guys. And you've got to tell me if you understand or don't understand anything. Okay. All right. And 13 is done. That was question number 13, right? Now we're going to skip question 14 for now. Question 15. Okay. Question number 15. I think you're getting a hang of this, guys. If you knew the next question was 15, very good. 9 minus 4x squared. Okay. Integral dx. Yes. So what is your x raised to the power n plus 1? If you said this, you're right, because it's in the denominator. And your x raised to the power n is x. So you're going to get it. It's very easy. So 9 minus 4x squared is equal to t. And then you differentiate on both sides. So this becomes 0. This becomes minus 8x is equal to dt. Correct? Oh, sorry. Minus 8. Minus 8x dx is equal to dt. Okay, so x dx is equal to 1 minus 1 by 8, because I took minus 8 to the other side, dt. And substitute. So integral. I'm going to do this very quick so that I don't waste anyone's time, because now it's more intuitive. Okay, so 1 by t, and then you have x dx, which is minus 1 by 8 dt. Okay, so integral of 1 t raised to the power minus 1. No, I'm not going to do t raised. Now this is very interesting. See, no, I'm going to put it as 1 by t, and minus 1 by 8 comes out, right? Minus 1 by 8 dt. Now what is integral of 1 over t? Now if you did the same thing as I did, took it up and t minus 1, never do that, because if you see the first formula, if you remember, n should not be equal to minus 1. If I took this up, which you can do, it's not a wrong thing to do it, but the thing is, you just get confused and you try to apply. If you did this, you were thinking of I would do plus 1 divided by that. It wouldn't work. Okay, it wouldn't work at all. Instead, you should know by now it wouldn't work, because you would get a 0 in the denominator, and that would be infinite. You don't want that to happen. Okay, so what do you want is, what is integral of 1 by t? And you have it right here. Again, this one is log of x, right? So it is minus 1 oh, okay, let's see. Okay, is equal to minus is equal to, all right, minus 1 by 8 log of t plus c. And what is your t value again? Let's have a look. Again, this was your t value, you remember this, and this was your substituted value. Highlighting this. Okay, 9 minus 4x squared. Okay, minus 1 by 8 log of 9 minus 4x squared plus c, the absolute value, plus c. So let's confirm question number 15. Let's see. Yes, it is absolutely correct. And this is question number 15. Good. How many questions are we now? 1, 2, 3, 4, 5, 6, 7, 8, 9. So 9. So we still have a long way to go. Okay. So what is the next set of questions I can see that requires no. So this was the last type of question with respect to what I thought of this. So x raised to the power n plus 1. So you had 9 unique questions. So remember, questions 1, so questions 1, 6, okay, 7, 8, 9, 11, 12, 13, and 15 are absolutely the same. If you understood what I said in this video, you would be able to do this without any trouble, without any absolute trouble, right? If you followed this, you're safe. All you have to do is follow these two conditions. Very simple. Very simple. It works. Okay? Correct? Now, of course, there are some minor ones, like question number 7, if I'm not mistaken, 7 and 11 for the second case. So 7 and 11. Okay, 1 minute. So the second part, in which x is equal, applies for questions 7 and 11. And a unique case, and it applies for this as well, is only when you have a quadratic and a linear equation in the same, which is question number 9. This was the tricky one. Okay, other than everything was the same. Everything was the same. Okay, so in the next video, what we're going to look at is the unique case of log of x, right? Because the log of x is a very unique case, and I want to do this with you. This is another case that we're going to study. So now you did with exponentials and exponents or exponentials? Okay, exponents, sorry. Exponents of x raised to the power n plus 1 and x raised to the power n. Simple. Next video is going to be about log. Okay, so hit like, share, and subscribe. Tell me what you thought. Do you like this type of video? Do you want more of these kinds? And thank you for your time. Thank you for watching. And please like, share, and subscribe if you found this useful. Thank you.